My name is Kiersten.
My name is Alexis.
And we are going to be showing you how bouncy balls are made and how you can even make one right in your own home.
So today we're going to be making two polymerization reactions. So polymerization is basically when we're making a polymer chain. So what is a polymer? A polymer is consisted of tiny subunits called monomers, and they make up a lot of things that we see day to day, like plastic, like silicone. There's organic and inorganic polymers that we see every day. So today we're going to start with a DIY bouncy ball that you can make at home. So Kiersten is going to be making our DIY bouncy ball.
Yes. So first we're going to start with glue. So take 2 parts glue, and I'm going to take 1 part cornstarch and put it in with the glue mixture. Then we're going to mix that up together until it's fully combined.
So what's going on here? So glue is a polymer known as polyvinyl acetate. But glue is very liquidy, it has a lot of liquid properties. So what's happening is the cornstarch comes in as a thickening agent and kind of sticks to that long polymer chain. So now we're getting more of a solid-like consistency.
Yes, and now we're going to take our borax, and with the borax we combine it with water. Most ideally you want to use more water, and then we're going to take that and put it into our solution. And then we're going to mix it up together.
So whenever we add the borax comes in and takes these polyvinyl acetate chains and does what's called cross-linking. So the borax will come in as our cross-linking agent and connect these two polymer chains to form more of like a lattice and more of a solid. And so that's why we see this polymerization reaction.
Yes, and now what we're going to do is we're just going to knead our mixture until it becomes more of a ball solid shape.
We're doing this to make sure that the polymerization reaction happens throughout the whole thing, and so every molecule of polyvinyl acetate alcohol can react with that borax.
We're rolling it up, mixing it together, kneading it. We have our completed bouncy ball. So this is how it bounces. Very cool.
And now, to contrast, we're going to be making what's known as a super ball from sodium silicate and ethanol.
Yes, so we're going to take our sodium silicate, this is 10 milliliters of sodium silicate, and then we have our ethanol, and we're going to take 2.5 milliliters of ethanol. So we're going to put our sodium silicate in the beaker, and then we're going to put our ethanol as well, and then we're going to recombine it.
So in this reaction, we have a similar polymerization going on. So the sodium silicate is an inorganic polymer, and so that ethanol will come in and cross-link via a dehydration synthesis.
I just knead it with my fingertips, and as you can see, it's already become more solid very quickly. However, for time's sake, we have one pre-prepared, and so this is what it looks like all done, and this is what it looks like bounced. Very bouncy, and this is what a commercial one looks like, and so if you join them together.
So why do we observe different properties between the 3 bouncy balls? Well, our experiment goes into that. There's 3 big differences between the DIY bouncy ball that you can make at home versus the sodium silicate and ethanol one. So the first big difference is that this is an organic polymer versus an inorganic polymer. And so obviously different elements will react differently, they have different properties, but also the DIY bouncy balls, they have bigger molecules, and so they can't get as close knit together versus these ones, they're smaller and they're simpler, and so they fit more like puzzle pieces, and so they're able to build that 3D lattice, and so they're able to become more compact and become more solid-like, and that's why you see the malleability in these DIY ones versus the solid structure that you see in the sodium silicate. And then lastly, the way that the polymerization happens, these ones are hydrogen bonded and then these ones are covalently bonded. So these hydrogen bonds are not as strong as covalent bonds, and so therefore they have weaker interactions, leading to its more liquid properties versus the more solid properties of the covalent ones.
Thanks for listening, and gig 'em.